This is just an 8 slides. So in here, we'll discuss the algorithm and then the data structure. So for the topic for this one, understanding data structure and algorithm is the fundamental of computer programming. And then this module focuses on defining data structure and constructing algorithms. Okay. So the first one is algorithm. So in here, you guys will be able to know how to, do some problem solving, basic problem solving concepts, properties of a good algorithm analysis, and then what is this big O notation, and then constructing an algorithm. And then here's another major topic, which is the data structure. So of course, we'll discuss what are the types, what are the importance, operation, and then the data structure in Python. So for the learning objective, of course, to define the structure and its importance in developing a program. And then second is create a good algorithm. Okay. And well, this is additional information, but doesn't really matter that much. Anyway, let's start with algorithm. Okay, so we have an example here. Let's see, 3-jug riddle. So a milkman carries a full 12-liter container of milk. So he needs to deliver exactly 6 liters to a customer, but the customer only has 8 and 5-liter jugs. So how can the milkman measure exactly 6 liters of milk using only the 8 and 5-liter jug? Okay, so with this, probably you're going to get some measurements. Probably you're going to assume that this is the 6 liter, etc., etc. And then you're going to assume that this is already like the 8 liter, or I don't know, maybe right here or right here. So the same with 5 liter. So with that, of course, you're going to do some, or you have to follow some steps, or let's say analysis, okay, or let's say background checking before you can do that one properly. So the first thing that you need to do is, of course, problem solving. So the above scenario is a good example that shows how logical thinking plays an important role in finding a perfect solution to a problem. So indeed, there are lots of ways to solve a problem, but there will always be one best solution, and that will be based on how much time and resources we spend solving. So it's like saying that yes, all of us will be able to solve that one eventually, in due time. And of course, we have to find the fastest way on how to solve this problem. Okay. So with that, computer problems are very much the same with other forms of problem. Okay. So programmers always aim to look for a solution that is efficient with respect to runtimes and computer spaces. So these solutions are called algorithms. So that is why we run a lot of algorithms and then compare them and then try to see which one is the shortest time that it was able to solve that specific problem. So with that, of course, you're going to remove all the, or let's see, not going to use, okay, the algorithms that will take longer than the, let's say, one remaining that is shorter in using a time, or it's one, it's like a time spent in solving that specific problems. So algorithms are known as a process to be followed in solving computer problems. It involves mathematical and logical procedures. Algorithms can be widely used in various areas and computer programming, mathematics, and daily lives. Okay, so this is the first step. So problem solving, so choosing the best algorithm. Second one is properties of a good algorithm. So this is an algorithm that you must have, okay, in your, let's see, program or code. So you must have a well-defined input and output, okay? And then of course you must have a finiteness that, stops after a finite number of instructions are executed. So you don't want to have a, for every loop wherein it will not end anymore. So it's okay if it will end after an hour, after 2 hours, as long as it will stop. That's what's important. And then probably you can just come up with another algorithm and then check again if it can solve that one in a shorter span of time. So that's what we mean by finiteness. Okay, so it doesn't have an endless loop. Okay, and then an algorithm must be precise with respect to the problem. Okay, it outputs what is required, and then it must be feasible. All steps are in simplest form. Okay, Third one is algorithm analysis. This is another steps that you can do in order to solve this kind of problem. So algorithm analysis refers to the analysis of the complexity of different algorithms and finding the most efficient algorithm to solve the problem. So we have two variations for this one. First one is the time complexity that you need to analyze. Okay, so this is the amount of time needed to perform a specific number of steps. And then the second one is the space complexity. This is also included, so not just the fastest algorithm, but also the storage or the space that you're going to consume your memory. Okay, so this is an amount of memory space. So we have two examples right here. We have this first code and then this second code. So you guys don't need to worry about how does this one work. So just take a look on this one. So we have this variable fact and then print fact and then five. Okay, so the same with this one, define fact, which is a different variable name, and then of course different steps or algorithm. Okay, but both of them have the same output or result. So this variable will multiplied by 5. So just note that def is used to define a function in Python, and then syntax, def function name. So two functions fact, this one fact, and then fact2n, or the first fact or the second fact, is used to compute the factorial of a number n. So these two functions provide the same output. Okay, they have the same output with the same amount of codes. Okay, so if you're going to take a look at this one, wow, we have 1, 2, 3, 4, 5, 6. Okay, we have here 1, 2, 3, 4, 5, 6. So let's just say that we have the same output, and then we have the same amount of space that we will consume. So when it comes to algorithm analysis, they are equal in both. However, using a software, let's say Jupyter Notebook, to analyze the runtime of the programs, let's say the first one and then the second one, almost spend the same amount of execution time. But when n is now equal to 50, this is now where they will differ with each other. So the say fact 50 takes 9 microseconds, while the second fact, while running 50 times of that one, it will take you 15 microseconds. So as you guys can see, the first one will take a shorter time to solve or to finish the entire algorithm, while the second one will take longer by 6 microseconds to finish the entire algorithm or loop. Okay, so the execution time shows that the first algorithm is faster compared to the second algorithm involving recursion. So this example shows the importance of algorithm analysis. So in the case of large inputs, the performance difference can become more significant. So yes, we could see that at first they are equal, let's say first 10 values or first 15. But when it comes to, let's say, bigger inputs, let's say 50, 100, 500, that is where you will see, the slight difference. Okay, actually, it's just a microsecond. We won't be even be able to notice the difference between those two. Okay, but of course, with correct application, correct software testing, correct runtime testing, you'll be able to check that this one only runs 9 microseconds and then the second one runs 50 microseconds. Okay, actually even millisecond, we cannot notice that one anymore. Okay, if it's maybe second, or yes, of course, a minute is already obvious. A second is still not that obvious, but you can already notice that one. Okay, but in here, it's micros. It's super fast. Anyway, they still have a difference, and then the first one is the winner. Okay, so are we clear so far up to this point? Letter C, algorithm analysis. Can you guys follow so far? Hello, are you guys still around?
Yes, sir.
Okay, so you guys don't need to check this one out right now. Just listen on what I'm, saying. These are just concepts that will help you on how to, uh, solve things, okay, in the correct manner. Okay, this is by following these steps. So the next one is the big O notation. So big O notation signifies the relationship between the input to the algorithm and the steps required to execute the algorithm. So it is denoted by a big O followed by opening and closing parentheses. So inside the parentheses, the relationship between the input and the steps taken by the algorithm is presented using n. Okay, so we have some examples here. So the following are some common forms of big notation. So we have the constant time algorithm, so the O, and then of course we have the constant value, let's say 1. So this one takes a constant amount of time to run and not dependent on the size of input. So n is equal to input, please enter a numbers. This is a line wherein it will require you to input a number, and then after inputting a number it will be printed and the number is equal to and whatever is that n that you have inputted. Okay, so in here, regardless of your input, this will give you the same amount of time. Okay, because this will just simply print whatever is your input. Okay, as simple as that. Okay, so any value of n input from a user doesn't make any difference with execution time of the program, since it only performs print once. Okay, so this algorithm is just like a, you know, neutral. Okay, this one doesn't really help you in knowing what is the best one and what is the worst one, okay, or what is a bad one. So it will only be noticeable if we have this kind of expression, or let's see, algorithm. So the first one is logarithmic time algorithm, or O and then log of n. So running time grows in proportion to the logarithm of input, so log to the base 2. So we have this sample code right here. X is equal to 1 and then n is equal to, again, this will require an input, but strictly integer. Okay, and then while x is less than n, then x is equal to, so it's incrementing by 2 or multiplied by 2, okay, depending on the last number. So we have an initial number of 1, and then the will be multiplied by 2, then of course it will become times 2 now, and then 2, and then of course the last value is 2, right? So 2 times 2 now is 4, and then it's just keep on doubling. So 1, 2, 4, 8, 16, 32. So that's how this one work. Okay. And then you're just going to print x as long as this condition is true. So x is less than n. So I think it would be better if we will test this one out. Okay, just be on the side, guys. Ano dita?
Yes, sir.
Dita. All right. So I think I already created that one yesterday. Module 2. Okay. Okay. Hindi na again. Okay. Let's start. Fresh one. X is equal to 1, and then we have integer, just put a number, while x is less than n, then x is equal times 2, and then print x. There you go. So in here, it will ask you to, a specific number. Let's say, let's follow this one for now. Let's say if n is 8, the algorithm performs 3 times. So in here, it will perform, the 2, 4, and then 8. So we have 3 loops if we have a value of 8. Now, what if we have a value of, let's say, 20? So in here, it will do 5 times. As you guys can see, the bigger the number, or let's say the bigger the input, the longer it will take for this algorithm to perform. So depending on the amount of number, then yeah, that's the time that it will consume. Okay, so this is one example of logarithmic time algorithm, okay, using big O notation. Okay, so are we clear so far with this logarithmic time algorithm?
Yes, sir.
Yes, sir.
Okay. So the next one is similar with the logarithmic. This one also grows directly, proportional to the size of its input. So of course, the larger the input, the longer the execution time. It's just that in here, instead of logarithmic, we have a linear time. So n is equal to, again, it's requiring you to input a number and then 4x in range and then print x. So for example, we have n is equal to x. So let's try that one out. For x in range n, and then print x. Let's try this one out. Oops. Okay, so if we have 8 here, let's just simply follow this one for now. So as you guys can see, it just display the range from 0 to 7, or whatever is our input. Okay, so it will just display that one from starting from 0, and then wherever is the last value, or actually not the last value. Okay, wherever before the last value of your input. Okay, so it's only 0 to 7 since we've started with 0. This is 1, then of course we'll stop with 8. So it's 1 to 8 if it's 1, and then 0 to 7 if it's 0. So one more thing is that this one doesn't mean that, you know, this is the last number, and then we have a initial value of 0 as always. So that depends on the incrementation of your code also. If it's incrementing by 2, then of course it will perform 4 times only. If it's incrementing by 3, then it will perform 0, 3, and then 6. So it will perform 3 times only. But in here, this is just a simple way to I have an example of this linear time. So it's like 0 to 0, 1 is to 1, 2 is to 2. Okay, so if n is 8, then it performs the algorithm 8 times. So if we have, whereas if we have 100, then this will perform 100 times. Okay, but it's going to display 0 to 99. Okay, so yeah, that's it for the linear time. So we also have exponential time. So this is another algorithm or formula. So this one also grows in proportion to some factor exponentiated by the input size. For example, if big rotation 2 raised to 10 algorithms double with every additional input. So if n is equal to 2, then these algorithms will run 4 times. If n is equal to 3, then this will run 8 times. So kind of like the opposite of logarithmic time algorithms. So let's try this one out. For y in range n, print x. X, print x. What are we missing? Colon. The intention. So that's the importance of indentation. Okay. So if we have a condition right here, it should have one indentation below, meaning this is the one that will be executed if this is true. So the same with this one. Okay. The previous one doesn't know what to execute if this is true, because we don't add an indentation right here. So we must add one indentation for this to know that this is the one that must be executed if this is still true. Anyway, so let's try this one out. So it says here that if it's 2, then it will run 4 times. If it's 4, then it will run if it's 3, it will run 8 times. 4, I think, is 16 times. Okay, so let's start with 2 first. So as you guys can see, this one run 4 times. If we have 4, oops, my bad. If we have 4, then this will run 16 times. So we have 4 zeros, 4 ones, 4 twos, and then 4 threes. Okay, and if it's 5, then 32 times, I guess. Okay. So 5 zeros. Correct? Is it? Let me just check. 2 raised to 5. Is it 32? 16, 32. Parang sobrang dami. My bad. It's the one that I put here is 32. That is 1. So it must be 5 only. Okay. So we have 5 zeros. That's correct. 1, 2, 3, 4, 5. We have 5. And then 5 ones, 5 twos, 5 threes, and then 5 fours. So how many of ilan na to? 24 lines. "25 lines." Hindi ba? 2 raised to oops. 2 raised to 5. It's 32. Pero bakit hanggang 24 lang ba? 5, 10, 15, 20, 25. Is this correct? 2 raised to n. Depending on your input, our input is n. But if it's 4, this is correct. It's 16. 4 threes, 4 twos, 4 ones, and then 4 zeros. Hmm. 24 lines lang to eh. 5, 10, 15, 20. Actually, 25 lines. I don't know what happened. But anyway, this one is exponential time algorithm. So where do you guys think, you've made a mistake? 2 raised to 5 is 32, right? Not 24 or 25. Does anyone knows what is wrong with this one? With this input? Seems like it is true for, if it's 1, it's true. It will loop once. If it's 2, it will loop 4 times. If it's 3, it will loop 8 times. 3, 4, 5, 6, 7, 8, 9. Dito pa lang sa 3, iba na eh. 2 raised to 3, in here, it will give us a result of, 9, actually. Tama? We have 3 zeros, we have 3 ones, we have 3 twos. However, I don't know what happened, but it says here that it should be 8. It will only run 8 times, but I don't know what happens. I think this one is not applicable if it's 3 and above already, since it is already giving us a different result. Anyway, so this one is an example of exponential time algorithm. Of course, the higher your exponent, the more time that you will consume in solving, or the more time that you will consume to finish that algorithm, or that process. So yeah, this is to keep the third input and so on and so forth. So just try 2. Okay, this is true, and then the 1 it's also true. Okay, 2 raised to 1 is just 1. Okay, we only loop 1 times. The next one is constructing an algorithm. So to construct an algorithm is the simple as math problem solving process you learned during your early childhood education. The only difference is in computer programming, you have to make sure that every step is programmable so that there is a syntax available to perform the task. So here are the common steps involved in constructing an algorithm. So we have step 1 to step 5. The first one is obtain description of the problem. Second one is analyze the problem. Third one is develop a high level algorithm, and then the fourth one is refine the algorithm by adding more detail, and then the last one is review the algorithm. So in order for you guys to appreciate this one, so we have an actual example here. So problem statement step 1. So here is one of the description of the problem. So a 0 starts at 0, 0, okay, 0 column, 0 row. So in here, we don't read this one as row 1 and column 1. So this one is column 0 and then row 1. Column 0 and then row 0 rather. Okay, so that is why we have 0, 0. And then does anyone knows why we call this one 0? Right? Does anyone has an idea why is this 0? Okay, so can't we just call that one as a kangaroo? Because yesterday I've searched what is a 0, and then it says here so 0 is an integrated development environment and micro world that is reminiscent of Karel the robot and its descendants. So a 0 is a kangaroo-like, which is true. This one, it's a kangaroo-like animal living on a remote island in the South Pacific. Okay, so a 0 can pick flowers, plant them, or give them to an adjacent 0. Okay, so how to use 0? Of course, as you guys can see right here, we have this first example on how to use a 0. So a 0 starts at 0, 0, blah, 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 which is super similar with this one. So this is just a short, short fact with this kangaroo. So it says here that it is a kangaroo-like animal, okay, living on a remote island in the South Pacific. So I think that person wasn't able to confirm if it's really kangaroo or no. So it's a kangaroo-like animal that's really living in the South Pacific. Okay. So yeah, that's the history or short description of what a 0 is. Okay, so we have here 0, which is at 0, 0. So there is a flower at location 3, 0. Okay, so the first one is the column, and then the second one is row. So it's column by row. So 0, 1, 2, 3, and then it's still at 0 row. Okay, so write a program that directs the 0 to pick the flower and plant it at location 3, 2. So 3, 2 is somewhere 1, 2, 3, 0, 1, 2, 3, and then 0, 1, 2. It's around here, which is actually this one. Okay, so after planting the flower, the 0 should hop 1, space, ease, and stop. So it after planting the 0, okay, so it hop once, spacing, ease, okay, and then it will stop right there. So right now the 0 is at location 4, 3. Okay, so there are no other nets, flowers, or zeros on the island, which is true. So there are no other nets, there are no other flowers aside from this one, or other zeros aside from this one. Okay, so that is the problem statement. So we've just simply identified everything. Okay, and then what happens from the start up to the end. Okay, so the second one is analysis of the problem. So this is already step 2. So collect all important details from the problem. So the flower is exactly 3 spaces ahead of the 0. And then the flower is to be planted exactly 2 spaces south, going down of its current location, which is true. It's one already. And then the 0 is the finished phasing is 1 space east of the planted flower, which is true. So after after planting the flower, it hops once to the right side and then it stops right there. So there are no nets to worry about, which is also true. Okay. And then the next one is high level algorithm. So this one will you're just going to simply assign a name, okay, of all the objects found in the problem. So assign variables and functions. So let's name the 0 Bobby. Okay, so Bobby should do the following. So get a flower, put the flower, and then hop east once. So these are the steps that you should do, okay, or that should be done, okay, if we're going to have this kind of output. Okay, that's the high level algorithm. So the next one is the detailed algorithm that is based from the high level algorithm. So add more details to the objects. A good programmer doesn't write a program all at once. Instead, a programmer will write and test a program in a series of builds, and then each builds adds to the previous one. So the high level algorithm will guide us in this process. So the first one is, of course, based from the first step. So get a flower means have 3 times and pick the flower. So this is the elaborated detail from the step 3. Okay, and then the second one is put the flower. So put the flower means turn right, have 2 times
Sir,
to
sir,
plant the flower. Yes?
less than 1 minute na lang po yung ano.
Yes. Kita ko. Anyway, 40 seconds pa that. Last one. Hop is means turn left and then hop once. So that's it for the step 4. So as you guys can see, we don't have enough time anymore. So we'll just continue the rest, the step 5, up to the last on the part 2. Okay, so goodbye for now and see you guys on part 2. I'll just announce the link. Okay. Okay, so goodbye and see you guys on part 2. Anyway, so let us continue now. So the last step is, of course, review the algorithm. Okay, so analyze algorithm by identifying the good thing about it and its limitations. In other words, define the scope of the algorithm, what it can and cannot do. So the good one in here is the higher level algorithm partition the problem into 3 rather easy sub problems. So this seems like a good technique. However, of course, it has limitations. So this algorithm solves a very specific problem because the zero and the flower are in very specific locations. Okay, so this algorithm is actually a solution to a slightly more general problem in which the year starts anywhere and the flower is 3 spaces directly ahead of the zero. So with this analysis, the next thing to do is code the algorithm. Okay, or probably before you can proceed to the actual coding, try to eliminate these limitations. Okay, so with that we'll be able to improve more your step 3 and then step 5, step 4 rather. Okay, so that is the main advantage of reviewing your algorithm. So is it applicable in everything? Is it a dynamic algorithm? Can you apply it in more general sense? Okay, so if you can solve that problem right away after viewing the algorithm, then you'll be able to, save uh, more time once you have encountered similar problem. Okay, because what if the zero is started right here or right here? Then you cannot apply this one anymore. Okay, so you have to find an algorithm that is feasible. Okay, in more general sense. Okay. So that's it for the first major topic, which is the algorithm. So any questions or clarification so far from the start up to the step 5? Questions? Okay, so I guess none. So let us proceed now to the second major topic, which is the data structure. So this is the techniques to access, manipulate, and store data. So this is also a way of collecting and organizing data to perform operations. And this is also a building blocks of any program or the software. So in any, in any program, in any software, in any application, we always have a structure, okay, or a data structure. So we have two types of data structure. So the first one is built-in data structure, and the second one is user-defined data structure. So for the built-in data structure, so this is primitive data structures, and then this is a predefined way to store data where set of operations to be performed on the data are also predefined by the system. While the other one is a user-defined data structure. So this is a non-primitive data structures And structures, operations, and attributes were defined during the compilation or runtime. Okay, so for you guys to know the different types of data structure, so let's go down below right here. So we have the built-in data structure. We have a list, we have dictionary, we have tuple, and then set. While on the user-defined data structure, we have the stack, queue, tree, linked list, graph, and then hash map. So those are the the types of data structure. So built-in data, and then user-defined data. Okay. And then the next one is the importance of data structure. So I think this is a very straightforward thing. So as you were reading the description, you already know the importance of it. So data structure is used to handle the following challenges in software design. So number one is processor speed. The software must match the processor speed for optimum use of the processor. Okay. So in processing something in every process, of course, it has to follow some certain steps. So a structure is very, very important. With that, it will be able to know where to fetch, where to store, how to fetch, how to store, when to fetch, when to store, and so on and so forth. Okay, because if it's random, like you don't know where to fetch, where to store, how to fetch, how to store, then of course, it will be a big problem. Okay, it will not work properly. Second one is data search. So with the growing industry of data analytics, it needs a high-level data structure to handle its operation efficiently. Okay, I think this is very straightforward. And then the last one is multiple requests. So a data structure supports multi-threading ability of the processor. Well, of course, that depends on the processor itself and how many processes it can process at a time. Okay, so of course we have one time, one process, one output. Before, those are the first uh, processors. Okay, but of course right now we have the multi-threading, multi-processor processor nowadays. Okay, so multiple requests. And then we have the operations on data structure. Of course, we have traversing, insertion, deletion, searching, and then sorting. So I think this is also very straightforward. Traversing is to check each data in storage. Insertion is you're going to add new data in storage. Deletion is, of course, you're going to remove data from storage. And then searching is to traverse the storage in order to find a specific data. And then sorting is to change the order of the data in storage. Okay, so those are the operations that can be done under a data structure. So the next one is data structure in Python, which we had a while ago. Okay, so this is the example of the types of data structure, which is the built-in data and then the user defined data structures. So that's pretty much it for the module 2. Any questions or clarifications so far?
Done, sir. Clear, sir.
Answer.